when we talk about writing equations, you need to make sure that you know the meaning of several math vocabulary words. We need to know that sum means adding. You need to make sure that you know that a difference means that we're going to be subtracting. If we're going to multiply, you might see the word product. You might see some other words as well. Words like double the number, well, that would be to multiply by 2. Or you might see triple a number, and that would mean to multiply by 3. You also might see the word quotient, which of course means the answer to a division problem. So there will be a division problem somewhere in that equation. Divided by, of course, would mean to be doing division. Times a number, of course, would be multiplication. We also would hear things for addition that might say more than a number, or added to a number. Added to a number. You, for subtraction, might see the words less than a number, or 5 less than a number. You're going to start seeing equations written as sentences, and we have to make meaning from those equations. So the first word I see here is sum, so I know that's adding. And then of a number, this part right here, I'm going to represent with a variable. I can use any letter that I want. Typically we stay away from L's because they look like ones, but you could use any number. I'm going to use an N here in this case. You could use an X since that's what we've been working with. So it says the sum of a number and 6 is, well, is equals 20. So I can write an equation that's going to have a number and 6, the sum of that, which would be addition problem. So n is my number plus 6 is 20. Now I can solve that, of course, by removing 6 from both sides and getting that n is equal to 14. I would check that by substituting the 14 in for n, and 14 plus 6 is 20. Here's another sentence. It says the difference, which we're going to represent using subtraction, between 28 and a number is going to become our variable. In this case, I'll use x, is, that's equals, 22. So I know I'm going to have the difference, which is going to be a subtraction problem, between 28 and a number. Because 28 comes first in this case, I'm going to put it first. And x is going to go here. This is the difference between 28 and a number, and I end up with 22. So we can tell the answer to this is going to be 6 because 28 minus 6 is 22. Now here we have a product, which is the answer to a multiplication problem. And I know that product is 12. So I'm looking for some number multiplied by 4, so x times 4 equals 12. Well, this is not how we would write that, because if I had x times 4, I'd have x and x and x and x, and the way we know to do that is to put those two together. So I would have 4x equals 12. Generally in algebra, we don't show multiplication with this multiplication symbol. So here I could divide by 4, and I end up with x is equal to 3. Now with a sentence like this, it says 6 less than a number, this is going to be represented by my variable, is 2. So I broke that sentence apart. I know I'm going to have equals 2, but this time I want 6, here's my number 6, less than this. So whenever you see less than, this key word than, means that this one is actually coming first. So our number is coming first. I'm going to have the number x, which is my variable. I'm not sure what that value is. And I want 6 less than that. So I subtract 6 from that. So if you had the word from here, okay, if I said I'm going to take 6 from a number, it would be the same way as this. The number would come first, and I would subtract 6. And I end up with 2. So we would, of course, add 2 to both, or add what am I doing? I'm doing it in my head. So add 6 to both sides, and we end up with x equals 8. And if I subtract 8 minus 6, I do get 2. Okay, so here we have 5 more than. So more than we know is going to be addition. 3 times a number. 3 times a number. This is going to be my variable, and I want 3 times that. So if I have 3 of those numbers, I would have 3x. And I want 5 more than that. So I'm going to add 5 to whatever 3 times that number is. And it is, or it is equal to, 20. That's how I would break down that sentence and turn it into an equation that I can solve. So, of course, I could subtract 5 from both sides, ending up with 3x is equal to 15. And then to get 3x into 1x so that I can get the variable by itself, I would divide by 3, leaving me with x. And if I do it to one side, I do it to the other, so we get x equals 5. If I substitute that in my check, which I would of course rewrite the problem and do, I would end up here with 3 5s, which we know is 15, and when we add 5, we get 20. So that's the correct answer. Try these 3 equations and see how you do. Remember that every time you see a number, you're going to represent that with a variable. We have our is, which is our equal signs, and then decide using key vocabulary whether or not you are adding, subtracting, multiplying, or dividing, or maybe a combination of more than one of those operations. Pause the video and try it, then restart the video to check your answers. Okay, what we did there was this shows 3 times a number. I'm decreasing it by 7, so I'm subtracting 7, and that is 17. Try solving that equation, and we will check the answers tomorrow. Make sure to check it as well. Now, for number 2, we have the sum, so that's addition, of a number and 9. So I have the number, which I'm going to represent by x, and I'm going to add 9 to that, and it is 14. Find that answer as well, and the check. Now for number 3, we have triple a number. Triple means to multiply by 3. So 3 times a number, I don't want to write 3 times x, so I say that's 3 x's. So that's triple a number. Increased by means I'm going to go up, so I'm adding 4 is, so that's equals 22. Find the answer to that problem as well. We will go over the x value and the check tomorrow. Good luck. Rewatch the video if needed.